Hey, Ross Dragon Metals here. Today I'll be doing some non-destructive circuit board recovery. Well, why do this? Reason is simple: it increases the material yield, and there's a hell of a lot of plastic on this circuit board. Most have got quite a lot of plastic upon them, as you can see. Removing that plastic stops it from melting and burning during removal of silver solder. That's the silver solder here. As well as smaller components that need to be hot knifed or hot metal removed by a hot metal treatment or heat gun. And breaking off these components also can keep them in workable condition, so good for resale value also, increasing the yield of electronics. Also reduces pollution and increases the yield of solder recovered, due to every time that I have done this, massive amounts of solder will in fact stick to the components that you're stripping. For example, these tactile switches, in which case it'll always stick to the bottom of the legs, in which case I'll lose some solder. So this increases the yield quite a bit. Some boards that I've already stripped here, I've taken all of the capacitors off. There's a good reason for this. All of these can explode when heated. I've experienced this personally. It is not fun, and the explosions can be sizable. Trust me. Take capacitors off while stripping. These are covered in silver plating as well as extremely pure aluminium, so with small amount. Put all the larger components in here, that is large blocking diodes and any resistors over 2 watt. Here we have inducers and transistors and rectifiers by the look of it. So a variety of components. They're all good for copper and silver and zinc and other metals. Here we have resistors and blocking diodes. As you can see, a lot of them are in still quite usable condition due to the method of extraction. Just plucking them off with a pair of clippers, which I will show shortly. Here we have some ceramic coated capacitors and film capacitors. These can contain rare metals such as tantalum. And we have germanium diodes, zener diodes, those little orange looking things. Now, usually they would crack and explode and become destroyed during recovery, heat recovery. So there's another component that you'd be saving right there. I have lots of miscellaneous stuff here. Batteries, connectors, bits of camera, things like that. There's also some infrared diodes in there, type from TV remotes, and an inducer, that weird green thing. Also have some basic materials here, bearings, screws and heat sinks extracted from microchips. They're also worth a little bit. Here's all the good stuff in this one. Lots of silver timing fuses, as you can see, and lots of tactile switches. These tactile switches all contain small amounts of silver also. And I have a video of how much silver is in these little things. Check it out. It should be in my recovery videos in one of my playlists. And there's also some gold recovery materials in there, broken off boards. So it's definitely worth doing in order to save the materials from eventual destruction. Ooh. Sorry about that. Get a good camera angle is all. It's an early morning today that I'm doing this. It's extremely dark and wintry, but it usually is lately. October after all. So very simple to depopulate boards, as you can see. nothing special. You can't do it with this tool. I wouldn't be bothered doing it at all, since it'll take you far too long. I've tried using many different tools. Clippers are always the best. Just tear them straight off. You can see the silver there on the tactile switch, exposed, very shiny. See the little dot in the middle? Yes, I will do a video on that sometime, on how to get the silver components out of these tactile switches. It can be quite tough to remove, as you can see. But you've got to get them all, otherwise they will melt during recovery, which will definitely destroy these buttons. I know this from experience. It's always best to remove them like this. That and burning plastic creates drippies, plastic drips down the side of the board, which also destroys other components not even close to the switches. So there's more reasons for you to do this method. That increases the recovery yield also. Nice piezo buzzer there, piezoelectric buzzer. Got a germanium diode here to try and carefully remove. There we go. Very small germanium diode. Almost imperceivable, see it there? And they can be easily destroyed during this processing, so definitely worth removing. All the rest on that board will need to be stripped via heat. Lots of solder on that board. Old remote control by the look of it. We've got the old quadcopter board here. Nice silver timing crystal there. Be having that. As I said, I have a video on how much silver material is in each one of these tiny oscillators, timing crystals. Go check that out. It's an entertaining video. Moving capacitors, exploded materials. There's also some screws there. And everything else on that board is surface mount devices, as you can see, which will all need to be removed via the hot knife method or heat gun method. Hot knife is just dragging a boiling hot knife that you put under a blowtorch or some such across the material itself. It all just shaves off like butter. Pretty simple technique. I'll do a few more. Quite a few timing crystals on there. Move these capacitors and get them. Since there is silver in them guaranteed, although I have actually known there to be gold inside of a few before from high quality electric devices. So definitely worth collecting timing crystals. Oscillators, these things. Sort of just look like little shiny silver bars. Okay, that'll do. A quick look at the board, where the capacitors were, and you see those little shapes there, that's where the timing crystals once were, the oscillators. As you can see, quite a bit of mounting up here. All this will require further processing and storage and classification. And I have quite a bit to get through. but I've also done quite a bit. Well, till next video, in which I'll be doing some gold recovery.